videos. This one is for Eureka Math, Gage, New York, Module 1, Lesson 3 problem set. In this one, we already kind of talked about in the lesson how you can solve ratio problems by finding equivalent ratios. You need to identify the missing value and find that. You're going to find that missing value by using equivalent ratios, using a tape diagram, and using the giant one. So those are the two methods we're going to talk about. We talked about already today, and we're going to look at both those methods as we go through this problem here. Okay, let's go ahead and look through these problems. So, write an equivalent ratio that are equivalent to 1 to 1. Now, we've kind of talked about that because that's what we call the giant one. So, any ratio, I'm going to write these just as a fraction. We know that we can write ratios as fractions. So 1 to 1, so anything 3 over 3. We call these giant ones because we use those to find other equivalent ratios. You could also have 8 over 8. You could do anything 250 over 250. Key is anything over itself is going to be equivalent to 1 over 1. All right, so let's look at this next one, right? Two ratios equivalent to 3/11. And this is where we use that giant one. We use the tape diagram, but I'm just going to do these with the multiplication method that we talked about. On the multiplication method, we multiply it by what we call 1, a fraction equivalent to 1. So if we just multiply this by 2 over 2, again, that's just equivalent to 1. We often call it the giant one. So we would have that 6/20. And because we're just multiplying by 1, we haven't changed the value of it at all. So 3/11 is equivalent to 6/22. So 6/22 is a ratio equivalent to 3/11. Let's go here. 3/11. Let's use another one. Let's just go 5 over 5. So again, we're timesing. You don't have to put the box. I just like to put the box around it to show that it's a giant one. We're just multiplying by a fraction equivalent to 1. And that would give us 15 55ths, okay? So again, any giant one or multiplying 3/11 by any fraction that's any number over itself is going to become an equivalent ratio. Anytime we take the numbers in the ratio multiplying by the same thing, we create an equivalent ratio, and that's the important thing to know. Okay, let's look at 3 here. The ratio of the width of the rectangle to the height of the rectangle is, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our width is 9, and our height is 4. So that's our ratio to our width and our height. Now, if each square in the grid is 8 millimeters, what is the width and the height? So they're saying if this is actually 8 millimeters, and this is 8 millimeters, what's the actual width and the height of this? So we're just going to multiply each one of these by 8. So 9 times 8 would give us our width. So I'm actually going to write that up here. 9 times 8, because each square is equal to 8. So we have 9 times 8, and that gives us 72. And then here we have 4, and each one of those is 8, so we end up with 4 times 8, which would give us 32. Okay, so our width is 72 millimeters, and our height is, so we would have a width of 72 millimeters and a height of 32 millimeters. And that's just kind of an equivalent ratio. Those would be equivalent. 72 to 32 is equivalent because we multiplied them both by the same thing. Okay, let's go ahead and close this out and go on to the next. I put the next problems on the next page. So, for a project in health class, Jasmine and Brenda recorded the amount of milk they drank each day. Jasmine drank 2 pints of milk each day, and Brenda drank 3 pints. So that's the key is so we have Jasmine 2 pints and Brenda 3 pints. So what is the ratio of number of pints? Then we want Jasmine to Brenda. So Jasmine was 2 and Brenda was 3, so our ratio would be 2 to 3. Represent the ratio in a tape diagram. I'm just going to go ahead and do that down here. So Jasmine would be 2 and Brenda would be 3. Okay, so there's representing it in a tape diagram. So there's our B. If 1 pint of milk is equivalent to 2 cups, how many cups of milk did Jasmine and Brenda drink? And how do you know? Okay, the key is here, these represents pints, don't they? But we know each pint is 2 cups, so that means each one of these would represent 2, wouldn't they? Okay. And then, so that means this would be a total of 4, and this would be a total of 6. So that would be our justification there. So Jasmine drank 6 cups, so and so it was there 4 cups, and Brenda drank 6 cups. And our tape diagram justifies it. Right, the ratio of cups of Jasmine's milk drank to the number of cups Brenda made. So that ratio would be, I'll write it down here, D would then just be 4 to 6. Are the two ratios you determine equivalent? Are these equivalent? We could justify it with our giant 1. Tape diagram does it too, but let's go ahead and justify it with a giant 1 here. We multiply each of these by 2, we would have 4, 6. So that justifies that those ratios are equivalent. Okay. All right, so that's the homework that's the problem set for this lesson. Good luck. Let me know if you have any questions, and have a good day. Bye.